All right, I guess the hour is pretty much upon us. Thanks very much for coming along this morning. My name is Bryan O'Sullivan, and I am the CTO of a very, very tiny company that is so small, in fact, that calling myself a CTO is kind of ridiculous. We're 3 people, and our name is MailRank, and I'm here to talk to you about what it's like to run a very, very small and necessarily extremely lean startup using the Haskell programming language. So, you can, if you wish, take a look at these slides on GitHub. They are available in both source and easily readable form. So go ahead and clone that repository if you wish. And I'm going to hop off this slide pretty much straight away here. All right, so I got my start with Haskell back in about 1993. I was an undergraduate at a Trinity College in Dublin in Ireland, and I ended up going to Switzerland for a summer internship. And I brought one book with me because that was all I could fit into my bag. And it happened to be a book on functional programming. So that was what I had to read for 3 months while I was tromping back and forth to work in the Alps. And that got my interest pretty well kindled. And I was lucky enough to land an internship the following year at Glasgow University in Scotland, which is where a fellow named Simon Peyton-Jones was working. And if you have paid any attention to the world of Haskell, Simon Peyton-Jones is like the man when it comes to that kind of thing. So I was very fortunate in the places that I ended up as an undergrad. Now, in spite of that, when I graduated from university, I did a very common thing, which is I left the previous world of youth and innocence behind, and I started going into the world of earning my way. And for me, what that involved was initially actually working in Scheme. So I think I was one of the very few people in the world to be paid to hack Scheme for the first few years of my professional career. And that was really fun. And then went on to C++ and Java and Python and, well, you name it. But back around 2005 or so, my interest got sort of rekindled in Haskell. I think trying to remember why exactly that was, but I don't really recall at this point. But what I saw when I came back into that world was that there was still a huge amount of intellectual ferment in that community, and there were an awful lot of people who I had been familiar with a decade earlier who were still working with Haskell and doing research in Haskell. So a lot of really interesting stuff had continued to happen, and it kind of looked like the community was going to go somewhere, but I couldn't really tell where the somewhere was going to be. So back in I leapt anyway, and of course, not having done any significant amount of functional programming in over a decade, I was more or less starting from scratch again. And anybody who's tried to learn a completely new way of programming and a new way of approaching problems will be familiar with the idea that it's kind of daunting in the beginning. So back when I was getting my start in it for the second time, what I found was that there were no particularly good books. There were a couple of undergraduate textbooks that taught you the very basics of kind of what you'd call here in America CS 101. But that's not very appropriate if you've been programming for a decade, right? Meanwhile, there was a bunch of sort of tutorial-style information, but it was scattered all over hundreds of web pages and was very hard to pull together. And I spent a lot of time reading, I'd say, literally dozens of research papers, mining them for bits of information. Here's how I do this. Here's this interesting idea over there. So, you know, as recently as half a dozen years ago, if you wanted to learn this stuff, you had to be extremely tenacious, and you were essentially exercising your library science skills as much as you were anything to do with actual learning. And I was thinking to myself, you know, it would really be great if somebody would actually sit down and write a book about this stuff so that there was one place that you could go. Now, anytime you hear somebody say, there ought to be a such and such, or somebody really should do a such and such, it's a very good thing to bring a little bit of reality to the table and ask your interlocutor, so when are you going to get started on that? Because quite often that'll shut them right up. And in my case, it did shut me right up, because I was asking myself this question, and I actually decided, you know, what if I was to actually try writing a book about this? So I pitched the people at O'Reilly Media about it, and they were quite receptive, because they too were hearing that there was something going on with functional programming, right? It was kind of in the ether at the time. And I found some people to work with me on it. One of them being a guy named John Goertzen, who is based in Kansas, which I believe is somewhere near here. And another guy was a fellow named Don Stewart, who at the time was a PhD student at Sydney University in Australia. Now, at the time we started working on the book, and in fact until quite a while after we had finished the book, none of us had met in person. We had only interacted via IRC and email. So it was pretty trippy writing this, what turned out to be quite a big fat book with two other people that I had never actually dealt with. I recommend the experience. We started work in mid-2007 and finished about 14 months later. So the book's been on sale now for about 2.5 years, and it continues to sell very well. It's pretty gratifying. It's also available online for free. So if anybody should come out of this talk interested in going, oh yeah, I would really like to learn Haskell and see if I can find some places to apply it, you can just go to realworldhaskell.org and read the entire thing without having to buy any paper at all. So, while I was getting my feet wet with Haskell, I had been in the startup world in the Bay Area for quite a few years. I had worked on embedded systems, I had done Linux kernel hacking, I had worked on supercomputer stuff. It was all kinds of crazy interesting work with not an awful lot of, consistency from one job to the next. I preferred to go to interesting things rather than to stay in one particularly narrow niche. But while I was writing the book, I thought that it would be wise to have a regular day job for a couple of years, because if you're really trying to burn the candle at both ends, you want at least one end of the candle to be slow burning, or else that's going to be the end of you pretty fast. So I spent a couple of years at a company named Linden Lab, and that was where we worked on a virtual world named Second Life. But then, of course, the hunger started to hit, right? So I finished the book while I was at Linden Lab, and took probably 18 months or so to just kind of relax. And towards the beginning to middle of last year, I was beginning to think, man, it'd be really nice to actually start another company again and actually do it from scratch this time. So previous companies, I had been an employee, and there's, as it turns out, a huge difference between being employee number 1 or 5 or 7 at a company and actually starting the whole thing for yourself. And I was very interested in knowing what that starting thing would be like. So I started having chats with people that I used to work with, going like, yeah, what can we do? And we actually found for ourselves what we thought was a pretty compelling idea. And much better than that, we found somebody who agreed and had money that they were willing to give us, which is a very helpful thing when you're trying to pay your way while doing interesting and exciting work. And so we got going in about December of last year. So we've been in business now for almost a year, and we build a product that, in essence, is intended to help people to deal with the fact that they get an awful lot of email these days, right? So if you sit in front of a computer most of the day, you're going to be spending a few hours just trying to troll through your email pretty much every day. And as anybody who gets a lot of email at work will realize, most of your email doesn't actually matter, right? So it's up to us to try and find a way to help you to deal with the email that matters and not the stuff that doesn't. So our application is a hybrid. One of the things, if you're trying to help people who deal with email at work, is that you'll notice is like, if people have a work problem, then perhaps they will be willing to pay some money to have you assist them with that. So a very good direction to be moving in, if you're doing that, is the Windows environment, because it's still very, very widely used in the corporate world. And so our desktop component is written in C#, and we have a cloud component too that the desktop part talks to. And the cloud stuff is what's all written in Haskell. So of course, starting a company is kind of a scary thing, right? You have somebody who is hopefully willing to fund you. You have an idea that you believe in, but everything is kind of powered by faith, right? Everybody is running on hope. And you become acutely aware of the risks that you are incurring and the risks that you're essentially passing on to your investors, with every decision that you make. So it's definitely a situation where I found myself going like, okay, I need to make some decisions that I'm pretty comfortable with, that are things that are going to get us to market and have us produce something pretty pretty sane in a reasonable amount of time. So some of the decision criteria that I had early on, right, much as I like Haskell, if I thought that it was a completely inappropriate language, there's no way that I would have said, yeah, we should totally sign up for this. Or, for that matter, if I thought, I think it could work, but I don't know it well, I'm not very experienced, wouldn't have chosen it either, right? Because there are plenty of other languages that it's pretty easy to bring a product to market in. So can I be productive in it? Can I find people to work with me on a product in this? And of course, do I know the terrain well enough to be able to avoid kind of nasty pitfalls, holes, and other sources of risk that you might necessarily be able to anticipate up front? And these are not criteria that are specific to Haskell, right? That would be true of pretty much any technology or approach that you'd be using in the early stages of a high-risk project. So it's not Haskell specific, and it's not startup specific. So knowledge of the language itself is not necessarily a huge roadblock, right? So I started writing C# for the first time in, let me see, December or January. Had never written a line of it before, and it's nevertheless worked out fairly well for us. So, I was a Haskell expert and was confident that I could get somewhere with that, but had never written any C# and was wondering, like, how is this going to be? But that was an absolute prerequisite to getting anything done on Windows. And of course, I had never used an IDE before December or so of last year either, right? I was happily sitting in Emacs and VI. And so it was pretty trippy to fire up Visual Studio for the first time. And anytime I'd move the mouse around the window, all this stuff would pop up all over the place. And I was like, wow, this is wild. It's like the 21st century. So hiring people then is another interesting thing when you're working in a sort of a leading-edge language that has a relatively small population around it. So, of course, there are not very many people who are familiar with Haskell, or for that matter, any other kind of functional programming language out there. You can find roughly comparable numbers of Haskell, Scala, Clojure, Erlang people, and they all tend to be in pretty high demand. And an expert in any one of these languages is likely to be an extremely productive person. You could get them writing, production systems in Bourne shell, and they would probably do relatively okay. Naturally, they'll be faster in a language that they're actually happy in. But the basic idea is that people who are really good at some of these things, you could put them to work pretty much anywhere, and you would feel lucky that you had actually gotten them working for you. So it's not so much the fact of knowing Haskell that seems to be the criterion of choice in my experience, because I've done a lot of hiring at previous jobs, right? It's the fact that you're interested in that signals that there are other aspects of you that might make you a suitable person for an intense environment where you have to learn a whole lot of different things. And of course, there are plenty of people who are very interested in these subjects out there. So even if you can't find an actual expert, you're quite likely to be able to find somebody who, if they're able to articulate an interest, are likely to be a good fit for your needs. An interesting thing, though, about trying to hire people is, you look at 10,000 resumes over the course of a decade, and you find that if certain skills are really widely distributed in a population, they become completely meaningless, right? So the fact that, for example, somebody has C# on their resume doesn't tell me anything. It would be like, this programmer has a head. That's a widespread characteristic in the population, and the possession of a head is certainly a prerequisite for being able to do your job, but it doesn't necessarily tell me that you'll be able to do it well. So, I'm not claiming that knowing Erlang or knowing Haskell or knowing any of these other obscure languages necessarily means that you're good, but it has a certain helping me to filter through things efficiently trait. And for example, one situation where that has changed over the course of the past decade or so is that when I started doing Python work about 11 or 12 years ago, it used to be that if you knew Python, the chances were that you were one of these people who was interested in picking up new things, might do well in a startup. That's not so true anymore. And probably the same is true of Rails, because it's very widely used now, but I don't know so much about the Rails world, so I won't make any strong claims there. Pardon me for a quick second while I have a sip of coffee. Right, so what does it actually look like to be working in crazy moon language on a day-to-day basis? It's actually remarkably similar to environments that you might already be familiar with. So for me, working in Haskell involves, typing in a couple of lines of code, loading those into my interactive interpreter, which is named GHCI in the Haskell world, and hoping to God that I don't get any errors out of it. Because the very first thing that at least happens to me, and I don't know how many other people it happens to, when I write a few lines of Haskell code, is that I get back some type errors saying, Brian, this code that you wrote makes no sense. It is not internally consistent in even the slightest way. And so I try and, bang away at some of those errors until they go away, and then load it into the interpreter again, and eventually I have code that the type checker believes makes some sense. And that's a source of great rejoicing, even if you do it on a daily basis. And then, of course, start working on using this code interactively, making sure that it actually behaves as it more or less ought to. Then finally, actually turn it into a bit of native code that runs. And it's a very fast cycle, right? So I'll typically be doing this dozens of times per hour, but not necessarily running any native code more than a few times an hour. So it's a very, I think the fact of having an interpreter handy that you can load definitions into is extremely useful. If what you're used to dealing with on a day-to-day basis is a much more compiler-based language like Java or C++, you're missing out on this fast turnaround, and that's too bad for you. So what's different then about working in this environment from working in other situations? As I mentioned, the edit and then dump it into the interpreter way of doing things feels like the Lisp that I was doing 20 years ago, and that's kind of a nice thing, right? Because otherwise, Haskell is actually a really different environment from Lisp, and we lack some of the things that you can do with a really good Lisp environment, like I don't know how many people in the room here have ever actually worked with Lisp, but it's really trippy. Like, you can redefine functions on the fly while your programming is executing, and we don't have those kinds of capabilities in the Haskell development environments that I work in. There's nothing to say that you couldn't do that, it's just that the tools don't support it right now. But those are really great things to be able to do. The type checker, on the other hand, certainly makes things a little bit more fun. So on the one hand, you've got this beast telling you, no, your code doesn't make any sense. On the other hand, a whole class of bugs is completely eliminated just mechanically without you having to lift a finger. And of course, the one downside to working in Haskell is that we don't have particularly good IDE support. There is IDE support in Eclipse, and there's a standalone IDE called Lexa, but I don't actually like using either Eclipse or Lexa, so for me it's Emacs and VI pretty much all the way when I'm writing Haskell code. And that feels exactly like it did when I was an undergraduate working in 1994. In fact, my .emacs file still contains a whole ton of code that's like 15, 20 years old now, which is pretty scary. So speaking of 1994, by the way, to give you an idea of a similar to a startup environment, right? So I mentioned earlier that I was working at Glasgow University for Simon Peyton-Jones on the internals of GHC for a summer, which is, when you're 20 years old, kind of an amazing environment to be in. And I was, one of a small number of undergraduates that were working in the computer science department there at the time. And we had a whole bunch of graduate students and a whole bunch of postdocs, all sharing a whole bunch of shared space. So there was a computer lab with a whole pile of, there were some DEC stations, there were some Suns. Like, some of these machines could do 20 or 30 million instructions per second. It was really impressive. And we were a pretty tight-knit crowd of people. We would go out to local restaurants. We were particularly fond of Indian food and spicy pizza. And, have a few drinks, come back and play Go in the evenings. And there's something about coding in Haskell and playing Go that go hand in hand together, which meant, of course, that as a very young person who was neither any good at Haskell nor any good at playing Go, I had the floor wiped with my ass on a regular basis. It was kind of tough. One of the people who was at Glasgow at the time was a postdoc who I was pretty friendly with, and he would be one of the people that I'd sort of chat with after we'd be going out and so on. And his name was Jim. And one night after we had come home from or come back to the lab after a particularly stiff post-coding drinking session, he stumbled off home and came in the next morning and said, Bryan, I had this kind of wild dream. And I was like, oh, that's very interesting. What do you want to tell me about this? And I could see that he had a piece of paper crumpled in his hand. And he said, in my dream, I met this beautiful woman. And this beautiful woman and I, we actually got on really well. You know, we talked for quite a bit of the dream, and it was really interesting chatting with her. And I felt this real chemistry. And I said, wow, that's pretty interesting. And he said, and you know, at the end of the dream, she actually gave me her phone number. I was like, wow, are you serious? And he said, and I woke up and I remembered the phone number. So I scrambled around for a pad of paper and I got a pen and I wrote down the phone number and I have it here. And I said, and what should I do with this phone number, Bryan? And I'm like, here, give it to me and I'll take a look and see what it is. And I opened up the crumpled piece of paper and looked at it and I said, I know this number. It's the takeout number for the local pizza place. So that's the kind of intensity that you'll find in graduate school or in a startup. It's an entertaining thing. So we have a cloud component in our product, right? That is written in Haskell that runs somewhere out there, wherever AWS has decided that it's going to land. And how does it work? Well, we have a load balancer in front of it that has an SSL certificate, and it proxies stuff off to us. Very standard kind of multi-tier application like that. The actual Haskell stuff behind the scene is vaguely RESTful. It's not a strictly REST application because it's fairly rare that if you're doing a back-end server app that it actually makes much sense to use REST in my experience. So what that Haskell code does is the desktop client communicates with it on a fairly regular basis, sends anonymized data up to it, the Haskell code bangs on it and sends information back. Of course, you know, the Haskell server-side code has to have a data store of some sort to actually manage all of its bits and pieces in. So initially, as a kind of, we can afford a little bit of time to do some experimentation with storage ploy, we chose a distributed storage system named REAC. And I'm sure you've noticed that there's been quite a bit of representation from the authors of REAC here at Strangeloop. And REAC has some really interesting and desirable properties to it. Namely, it is inherently distributed. There is not a central server that is responsible for keeping everything up. It's not one of these master-slave situations where if the master goes down, you've still got your data, but you've also got an hour or two of pain as you try and, switch over from the master to the slave. So there are many desirable things about REAC. And in fact, I was impressed enough with it to write a set of bindings for REAC that we subsequently open sourced. So those are available on GitHub if you're interested in trying out distributed storage with Haskell. Now, as good as our bindings are and as good as REAC is, for our particular purposes, it had some shortcomings at the time. The most severe of which was that we didn't have secondary indices. So you could only index based on one particular piece of information at a time. And if what you're trying to do is anything even remotely relational, you can model that without explicit support for secondary indices in REAC, but pain in the ass doesn't begin to describe the experience. So that was extremely unpleasant for a short period of time. And in addition, the awesome thing about vector clocks is that they tell you that your data is inconsistent. The terrible thing about vector clocks is that all they do is tell you that your data is inconsistent. So it's sort of the equivalent of having a fire alarm, but no way to put the fire out, right? Let me not understate the difficulty of writing a real application that actually tries to use vector clocks. The reason that all of the examples you will ever see about people using vector clocks in practice revolve around shopping carts is that shopping carts have the extremely desirable property of always wanting to get bigger. So for any kind of more complicated application, vector clocks are another situation where you'll be reaching for the hemorrhoid pads before you're done. I do actually hope to go back to using REAC again at some point in the future, but we actually switched over to a different data store, and the data store in question is, for at least the time being, MySQL. Now, as much as people like to rag on MySQL being all kinds of bad things, you know, people wouldn't be able to say bad things about it if everybody wasn't already using it. And if you've been around for a while, you will notice that no matter what environment you work in, anytime there is some sort of storage system in use, be it a USB stick, Dropbox, Oracle, or S3, people are going to find very bad things to say about it because people depend on their storage, and their storage always pisses them off. So you can't use the fact that people are swearing at their storage solution as a first-order way of going, well, this one must be good because people don't swear about it so much. This one, on the other hand, people swear about a lot. It doesn't really work that way. You have to do a little bit more digging before you can decide that something might be good or not. And in our case, I had used MySQL at several previous jobs, including Linden Lab, where we were pumping, golly, tens of thousands of transactions a second through it, and it was working reasonably well for us, especially since I wasn't on the database ops team. So it's actually quite a good piece of software, and so you shouldn't necessarily dismiss it out of hand and go, oh boy, I'm going to use Cassandra in my little two-person startup. You know, stick with something that works until you've proven the other parts of your business model. So, of course, after we chose MySQL, I switched over to the standard Haskell MySQL bindings and found that they were more awkward to use than I would wish. And so I spent a little bit of time writing a fresh set of MySQL bindings. And you'll notice that I had to write React bindings. Now I'm off writing MySQL bindings. There's a little bit of a theme emerging here, right? Which is that, at least for my particular purposes, I am interested in software that's going to be easy for me to use, and I'm interested in software that's going to be very fast to use. So it was worth it to invest a little bit of time in putting together a set of MySQL bindings that were going to be fast enough for my purposes and easier to use than the default bindings. So the amount of work that was involved in this was quite small, thank goodness, because when I was using React initially as our storage system, I had a fair sense that it wasn't necessarily going to work out, and so I'd carefully abstracted I am storing stuff from I am storing stuff in React. So switching over to I am storing stuff in MySQL was relatively straightforward. So after I was done with the real-world Haskell book, one of the projects that I worked on in my spare time was with a friend of mine who works at Google. His name is Johan Tibble. And we were interested back then in working with Haskell on high throughput and large-scale network-based applications. And at the time, the I/O subsystem in GHC was not capable of doing the job. It could handle high throughput, but it could not handle a large number of concurrent clients. And so we replaced a lot of this stuff. And at the time, this is right long before MailRank came into being, I had worked on the Haskell book, and I was now working on the I/O subsystem. You could kind of get the idea that at the back of my head, I had this notion, I really want to make this a better environment to be able to work in if someday I do a startup. So I wasn't explicitly doing this with the intention of going off and using it commercially later on, but that's how it turned out. So it was kind of handy that the facility was there. So what does that actually mean in practice? We have an I/O subsystem now that can easily handle almost 100,000 requests a second via a regular HTTP. Like, what am I trying to say? The HTTP servers that use this are very fast. They can do 100,000 transactions a second, have hundreds of thousands of idle clients talking to it concurrently, which means that, for example, you could use this as the basis of a Comet server or any other kind of long polling-based back end. And these are really nice properties to have. Now, 90,000 requests a second is a pretty damn good number, right? If you look at some of the other competing web servers out there in other languages, they generally don't get quite that good, especially when you consider the level of abstraction that you can reach in Haskell and the kind of concise server-side code that you can write. Now, based on top of this, there are two good web frameworks available. One of them is named Yesod, and Yesod is kind of the all-singing, all-dancing web framework. So if you're coming from a world of Django or Rails, it'll look somewhat familiar. It's not quite as featureful as Django and Rails because it hasn't been around for as long. On the other hand, unlike Django and Rails, it's really fast. And then the web framework that I use, which is somewhat similar to Yesod, is called Snap. And so that's what our back-end server sits on top of. So you have a Snap application, and it's handling a bunch of routing of information off to code that you're writing. You still need to be able to transmit your data back and forth between the server and the client, right? And these days, of course, most people tend to use JSON for that. Once again, we found ourselves in a situation where the standard JSON implementation for Haskell at the time that we got started was not quite good enough. It had all the features that we needed, but it was not very memory efficient and it was not very fast. So we decided that we would write our own once again. And that was something that we were able to get started on pretty fast. And this one is, again, focusing on ease of use and high performance. And once again, we've open sourced it so that if you wish to use it, you can. And I've been actually really pleased with the performance that we get out of this. I get emails on a fairly regular basis going like, thank you so much for writing this nice, fast, easy-to-use stuff, which is good. Other things that we had to build along the way are a resource pooling library that we can use in multi-threaded applications. So the resource pooling stuff is what we used to use for handling multiple concurrent connections to our React cluster. It's now what we use for handling multiple concurrent connections to our MySQL cluster. It's nice and generic, but it's also pretty straightforward. We also have a configuration library. So has anybody ever used a library called Configi in Scala? It's this quite nice library for working with application config, and this configurator library that I wrote is quite similar to it, right? You can very easily put a whole pile of application config in there. You don't have to write it in XML. You don't have to write it in some other kind of strange syntax. It's easy to deal with as a user, and you don't have to know Haskell if you're just trying to administer one of these applications. And we've written a ton of other libraries too. And fortunately for the world at large that is doing stuff in Haskell, most of the stuff that we've developed along the way we've managed to release. So it might sound like I did an awful lot of inventing of wheels to get all of these bits of infrastructure going, but remember the amount of work that I invested at any given point along the way was on the order of a couple of days. So I think that all of these things combined slowed us down by maybe a week. Compared to having them all existing. And of course, they all behave exactly the way that I wish them to. Somebody has a question. The question is, was Haskell the reason that I was able to do these things so fast? Well, there's probably a pair of reasons, right? One was indeed that it's really fast to develop solid code in Haskell. And the other one is that having been around for a long time, I've got some fairly strong opinions at this point as to how things ought to be done. And so I knew exactly what the design ought to be pretty much up front. And there's no substitute for kind of knowing what you want to do and doing exactly that. So that's more an experience thing than it is a language-specific thing. Another question down the back. So the question is, if you were of sort of intermediate abilities and you were considering using this, would that make sense? Given that I can pump this stuff out very quickly, but I pretty well know what I'm doing. Would that hold true? And I'm actually going to come back and answer your question in a couple of minutes because I had anticipated it before you asked. Okay, so when we're building our code, we use a standard tool called Cabal, and Cabal combines the properties of dependency management, installation of other libraries that we depend on, building the package itself, and then creating redistributable tarballs of libraries. So it's quite a nice tool. And there's a version of it called Cabal Dev that all works in a sandbox, and sandbox development is awesome. So it's very nice to have a environment that we can work in that does not depend on the particulars of whatever happens to be in my .bash RC. We use Jenkins for continuous builds, so all of the same kinds of things that you would expect to use if you were doing Java or some other language where you're thinking, continuous integration is great, right? We do exactly the same things using exactly the same tools. And in our case, the units of deployment are tarballs that contain native code executables, rather than, say, jar files or some other thing like that. So it's really easy to just ship around a tarball, unzip it, and then start running the programs inside. When it comes to writing reliable code, right, the type system is one great thing that makes it much harder to commit the kinds of trivial errors that are very common in languages like Python, where you forget what type your data is on the wrong side of an if. There's a library called QuickCheck for Haskell. I cannot say enough good things about QuickCheck. There is an explicit port of QuickCheck to Erlang. There is a QuickCheck-like library for Scala called ScalaCheck. There may be things that are QuickCheck-like for other programming languages. Seek it out, figure out how to use it, or write your own. Right? This stuff is just remarkably awesome. The difference between doing testing in QuickCheck and doing testing using traditional unit tests is unit tests, their efficacy is limited by your imagination, right? You can only test the couple of scenarios that you can remember to actually deal with, and you find yourself running out of steam fairly fast, right? You'll write 3 or 4 unit tests for a particular function, and then you'll go, oh God, I'm done, on to something else. Whereas QuickCheck uses the power of your handy-dandy random number generator to create, what should I put it, pathologically bad things for your code to be fed. And there's nothing quite like having automatically generated garbage to really flush out some of the badness in your code. And there is no way for me to overstate how much more effective this randomized property-based testing is than using unit tests. So if there is only one thing that you walk out of this talk with this morning, and I understand that it's very early, so it's quite possible that there will be only one thing that you walk out of this talk with, it is, I must learn about property-based testing. I must use property-based testing. You will be very, very glad that you do so. Okay, so clearly, with the type system and with property-based testing in place, then all Haskell code must be perfect the very first time that it runs, right? Yes, no. So there's a little bug from the deep history of GHC, the standard Haskell compiler, that is probably worth relating, which involves, as I've made allusion to several times now, sometimes when people are writing Haskell code, they make type errors, and the compiler will reject their code with a type error. Well, there was a version of GHC quite a while ago, about 10 years ago, that if it found a type error in your code, it would delete your source, which is a very interesting thing to have happen, right? Talk about rejecting your code as not behaving the way you want it to. So not all Haskell code always works perfectly. I believe that bug's been fixed, by the way. All right, so as far as then other moving parts are concerned, we have this sort of, I won't call it a user-facing application, but at least something that has to be online and is being interacted with indirectly via the desktop software all the time. But we also have some quote-unquote big data. Everybody loves hearing the words big data. Do you ever see people's eyes light up when you talk about big data to them? Big data, big data, big data. So we have some big data code that does a lot of linear algebra and makes awesome things happen in the background with double precision floating point numbers. This, too, is written in Haskell. The code is very compact, but it is also very fast. That makes me happy. And, of course, deploying our code is a simple matter of hitting Control-C and starting something up again from scratch. This takes a fraction of a second, and it's also possible to just redirect a load balancer at a new instance of a running application and have happy things occur with no apparent downtime from the outside world at all. So these are the kinds of things that you would be concerned about if you're trying to be at a startup where, for example, you get to sleep through the night because your application is behaving itself all the time. So as far as where we have gotten is concerned, we're pretty close to a public beta. We have beaten the hell out of our application using some testing tools that we wrote. And once again, we've open sourced our HTTP load testing software. I'm very pleased with the tool that we wrote. Its name is Pronk. And the name comes from that thing that gazelles do where they bounce up on all 4 legs. Pronk has some of the capabilities of tools like Apache Bench or HTTPerf, but it is much more mathematically solid on the backside. So it does very, very nice things for reproducible load testing with believable performance numbers that it reports to you. So we've also written a whole bunch of C# code. And so it's very interesting to compare and contrast our experience writing a bunch of production code in Haskell and a bunch of production code in C#. Now, C# as far as it goes, is actually quite a nice language. I was able to go from never having written a line of it to having a working application that actually did something meaningful for our initial proof of concept purposes in a day or two. And I was very happy about that. There are some aspects of C# that are particularly nice. So link, which is essentially monads transplanted from Haskell into a language where they're more likely to see a little bit of use, is actually quite nice. There are other aspects of C# that feel like, wow, it's trying really hard, and I'm not necessarily sure that I'm getting an awful lot of use out of this. And of course, working inside an IDE is pretty nice, right? Having all kinds of colorful fruit salad pop up whenever you do certain things on the keyboard is it's very visually appealing, especially if you enjoyed dropping acid in your youth. And of course, ReSharper is a particularly nice piece of software. So what are some of the interesting things then about dealing with C# if what you're used to is Haskell? Right, one of these things is that you have very limited local type inference in C#, and it's so achingly almost useful that it's kind of frustrating at the same time. I'm sure it's great if you've never seen any kind of type inference, but if you're actually used to proper type inference, not so hot. And some language features have this interesting property of looking like they're a good idea, but making you write code that is, well, shit. And in particular, there are these things called properties in C#, which are very similar to properties in Python. They are these smart getters where what you do is you look like you're just accessing a member of a structure or a class, right? You do A.B. Only when you do A.B.C, what's really happening is when you traverse over .B, some function is getting called on your behalf. Notationally, you can't tell from the outside that it looks like a function, but it's doing something tremendously clever that is going to screw you without you being able to tell. And not only is this language feature available, but a lot of Microsoft APIs make use of this language feature, which means that they are basically teaching you how to repeatedly screw yourself, which I am not tremendously happy about. And in particular, if you're dealing with COM objects, there's an awful lot of smart properties out there that will give you back a different COM object every time you access them, which means that your code will look like it's working, but will never actually work in practice because the garbage collector will clean up those COM references before they can actually be of any value to you. Not something I'm very happy about. In addition, concurrency in C# has, so far in my experience, not been my favorite thing ever. It's very similar to working with concurrency constructs in Java or C++, right? You have a lock keyword, which is kind of nice, so you've got exception-safe locking. But on the other hand, you still have to deal with manual locking. You've got mutexes, you've got semaphores, and a few other very basic constructs. It's really easy to use those things to create code that is not going to work at runtime, that's going to crash, or that's going to corrupt its own data, or that's going to deadlock. And in particular, after using software transactional memory in Haskell, right, running into some of these problems in C# feels like kind of going back to the dark ages again. And that's not to knock C# in particular, it's to knock basically every other programming language. So for example, you know, in our C# application, almost every really nasty problem that we have come across has been caused by the paucity of good concurrency constructs. And it's just murder, right? Some of these things take days to figure out what's going on, and it turns out to be a one-line change to the code that actually fixes everything up. So quite often from people who have not necessarily used software transactional memory, you will hear them say things like, well, it's got to be slower than using explicit locks, so it can't possibly be good. But, you know, an application that works is an awful lot faster than an application that doesn't work, and it's more valuable besides. So anytime you hear somebody say, well, it's got to be faster, and so that's got to be better, you got to be a little bit wary of that kind of reasoning. So C# is, in spite of those complaints, actually quite a decent language to work in. And there are nevertheless some drawbacks to it. So it's a mixed blessing. So the question then that the gentleman down in the back was asking earlier is, should you be using Haskell in the startup of your choice? And of course the answer is, it depends. You know, I'd be an unworthy salesman if I was standing up here and telling you that it was all sunshine and smiling babies. So supposing that you wished to use Haskell, right, or other arbitrary language of your choice. This is not specific to Haskell. You'd run into the same things with Scala or Clojure. Supposing you wanted to, right? The very first thing that you want to make sure is that you have enough bits that you can actually get stuff done in. And these days in Haskell, there are enough libraries that you can actually get most kinds of real-world tasks done in a useful way. The teaching materials are decent. Excuse me. The community is helpful and will assist you in getting things done when you run into roadblocks. So is it a slam dunk? You're going to be able to find people that you want to be able to work with too. It's not entirely a slam dunk, because bringing anything new into your environment is necessarily going to come with some cost and some risk. You want to make sure that you have the time to be able to afford it. So, for example, in our case, I decided that I would use React fairly early on. I already knew Erlang. I already knew how to think about distributed systems and how to write code using vector clocks and so on. So, but nevertheless, using React was still a little bit of a risk, and I decided after spending some time on it that that risk was not worthwhile. And in that particular case, it turned out that that decision was a good one, and I had enough room to make both the initial decision and to switch away from it. And as I say, I'm looking forward to going back to it at some point. But those are the kinds of things that you want to have room to do. If you're on a tight deadline and you have high risk in various other ways, like your business model hasn't been proven, or you don't know how to produce the application that you need to do in any language, then should you be switching to something new early on? I don't think so. That probably doesn't make sense. So if nevertheless you're working on a tight time budget and you have these ambitious plans and you want to use a new technology, then I will be happy to help you with liberating you from some of your money or other things that you might be finding too burdensome as you go. So where are we going now with our company, and what are our plans here in the near future, right? One of the things that I alluded to is that we have a paucity of people who know about some of these technologies. So I'm actually starting to teach a class to upper division undergraduates and graduate students at Stanford next week. I'll be starting on how do you build interesting code in Haskell and interesting applications in Haskell. My company is hoping to be hiring pretty soon, so if this is a world you would like to operate in, it could be that we have a place for you. And of course, we're continuing to develop this stuff. And I'm basically done at this point, so I'd like to open the floor up to any questions that people might have. Thanks very much. Yeah? So the question is, I talked about C# without saying explicitly why we need it. So we're integrating with an existing application, and all of its APIs are provided using .NET. So our choices were we could use C#, or we could use managed C++, or we could use Visual Basic, or we could use F#. And out of those, C# seemed like it was the most reasonable thing to use, and that's actually worked out to be true.
That application is Outlook?
That application is Outlook.
So could your problems with C# really be problems with Outlook?
Could my problems with C# really be problems with Outlook? No. Not in this instance. Yes. So the question was, why not F#? F# is a less mature language than C#, and I was already willing to accept a certain degree of risk by developing in this language for this platform that I was unfamiliar with. So I've been a Unix hacker for like 20-something years. Doing stuff in .NET was completely new to me, and there's frankly like an order of magnitude, if not 2 or 3, more information on getting stuff working in C# than there is in F#. So that's one of those instances where I went, you know what, I would really like to be doing stuff in F#, but it doesn't make sense for the business constraints that I have right now. Yeah, the question is, I mentioned 3 good books. What are the other 2? So Real World Haskell is obviously the one that I wrote, which I will be very happy if you pay for copies of. Then there's another one named Learn You a Haskell for Great Good, which is also available online for free. So if you go to learnyouahaskell.com, I think, that will get you to places that you will be happy with. And it's also got a very good reputation. And then there's a third book that is a more of a basic one called Programming in Haskell. I think it's called Programming in Haskell, written by a guy named Graham Hutton. And that's more of an introduction to programming book, but might be suitable for some of those needs. Down the back. The question is, how much does Quick Check rely on the type system? In Haskell, of course, Quick Check relies on the type system very heavily. But, pardon me a second. The Erlang port, which was written by the original author of Quick Check, doesn't rely on the type system because Erlang doesn't have one. And nevertheless, it seems to be pretty useful. So we have existence proofs that it's possible to port Quick Check to other languages and get good value out of it, which is part of why I suggest that you really learn about it. Yeah. Question is, am I using anything from the Cloud Haskell paper? And the answer is no. So there's a paper about this thing called Cloud Haskell, where Cloud Haskell is very similar to what you would look at as RMI in Java, or gosh, I can't think of the equivalent. So sort of the inter-process communication facilities that, say, Erlang has. It lets you do language transparent cross-address space messaging. That's not something that I ever really find myself pining for, in spite of having done a lot of RMI back in the day in Java. So no, I'm not even sure it's a good idea, actually. More questions? We've got time for maybe one more. Yes? The question is, are those lectures going to be available? No, this is our first time teaching this class at Stanford, and we want to get the bugs out before we start exposing it to the wider world. So at some point in the future, if we repeat the class, then chances are that we will try and make that stuff available online, or do it as an online course in addition to the real-world course. But while we're still figuring out the baby steps, not initially. Okay, thank you all very much. It's been a real pleasure talking to you this morning.